name is Enrique Romero Motta, and with me is Mery Peña, which is also a consultant. We are consultants from Decisiones Logísticas Consulting Group. I'm a senior consultant there. So we're gonna do the following things just to present it to you a business case. And I'm gonna give you a brief description of what DL do. Then we are going to move forward, to the business case itself, discuss some elements related with that, the business challenges, address it, and also the way we're working with that case, some elements regarding with the modeling issues. And then we're going to move, with why we use anyLogistix for that case. And finally, we are ending, let's say, with some results and some insights, some lessons learned from that. So let me start in a really, really brief way. Why? With some elements about Decisiones Logísticas. Decisiones Logísticas Consulting Group, it's a consulting group with more than 25 years experience on doing not only consulting services, but I can tell you more, creating hand-to-hand solutions with our customers. We are working closely with them, developing specific solutions to them in LATAM. And also we are using several tools such as supply chain optimization tools and mathematical model optimization techniques and everything related with that. And also we are using the latest technology, for managing these projects and getting really powerful results, as we're going to show you in a few minutes. As I already mentioned previously, with me is Mery, which was the project leader of the business case we're working with, and we're showing to you in a few minutes. So hopefully you enjoy the way we're present this business case and finally the results, because let me tell you something just to create a kind of an opening to this conference, and it's related with the way we used during this business case the anyLogistix software. We try to do it not the normal way, try to come up with different elements, try to, let's say, use in a different way, but getting really powerful solutions. So just wanted to be brief, and then let me move to Iovanna, which was the project leader, and when she's going to start, with the business case itself. So Iovanna, go ahead, please. The floor is yours.
Thank you, Enrique. Hi, everybody. My name is Iovanna, so let's get started. So first of all, we have to introduce you to the company. So this project was realized with a Colombian distributor of household staple products. This is a big company, and it has some or more 4,500 customers location in all the country. So these customers could be classified in 3 categories as local or regional distributors, institutionals, and neighborhood stores. So the portfolio of this company is too big. So it's around 6,000 SKUs. And for modeling, we group them in 4 categories. So the first is high turnover, the second medium turnover, low turnover, and chill products. So it's important to resolve that the portfolio of this company includes dry and frozen products, because that impact on the transportation costs, because each category should be transported in a specific vehicle. So for the dry products, we have a vehicle, and for chill products, another vehicle. So the first challenge and the most important question in this project is answer how many diseases and where they'll be located. So for that, we have to face a lot of business challenge that we see in this moment. So the first challenge for us is locate the number of disease, his profile, and the size of each of one, and the service area, or the cover of each disease. we have multiple constraints to assign that customers to our DCs, and that constraints could be logistical or commercial. For example, two of the most important constraints are the minimum number of customers to serve for opening a DC. This constraint is very important because it's understandable open a DC that serve less customers. It's not a financial option. So it's important to include. And a maximum number of customers to serve. In this case, that number is 500 customers. So it's important because it's more related to a commercial constraint in terms that that is too difficult to manage a big area to cover and a big DC. So there is the most important constraint, but we have a lot of more. The final business challenge is how to represent all the complexity of this network in the model, in the software, and how we can deal with that. So first of all, we group, as we see previously, the SKUs in 4 categories. We give to the software 7 options of size for the each DC, for choosing the size. We give the location of the customers, and there are many territories to visit across the country. And for that, we also have a big number of possible routes because we have a lot of options of visit and a lot of customers to serve. And the modes of transport related to the dry and frozen products. So to start to modeling, we start with the GFI module of anyLogistix. So we use the GFI module and we found and choose 40 potential locations for our disease. So it is the first step to define a possible location to our disease. And next to that, we use the network optimization module, where include the cost and other characteristics of our chain. So move to the network optimization model. We have some input. So important, our time horizon of the demand is 10 years. The DC costs that are associated to each area or each size option is here and is composed by fixed costs and variable costs. So in this case, in this graph, we can see the 7 options from 7,000 square meters to 25,000 square meters. And each option have related to the cost, the fixed cost in this axis, and a capacity in terms of throughput in this axis. So that is the graph. And also we have considered the inventory policies and an inventory carrying cost. Another important cost to we consider are the transportation costs. And it's important to say that the inbound transportation cost that is from suppliers to DCs is not included in this set of analysis. In this set of analysis, we are working with the outbound transportation that is from DCs to customers. So to model this cost in a proper way, we use 3 ranges for the distance. So we use a close distance, a far distance, and a standby. This is considered the geography and all the characteristics of our country. For the cost, so we have fixed and variable costs that are applied to each range, tools that are applied only for far and standby range, and the state that is applied for the standby range. And in the modes of transport that we mentioned previously, for dry products and chilled products. Why we choose anyLogistix to model? So for us, anyLogistix is a software that facilitates the path from theory to practice and help us to model these type of cases for support our decisions in network optimization, in strategic decisions. So it's important result the distance by roads that anyLogistix offers to us, and also the flexibility that we have to manage and use the constant constraints. So in this case, we use linear expressions, step functions, limit inputs, and limit outputs. The limit input is important because with this constraint, we can ensure that a customer is only served by one DC. And the limit output is important to ensure that a DC only can serve 500 customers in this case. We have to highlight the step function because with these functions, we can model the option of selection or choosing sizes for our disease. So it's very important, this function in this model. So next to do that, all the modeling and run the diverse scenarios, we have the following results. So the first is related to the outbound transportation. We're gonna see you all the logistics costs. And this is important. And the first because it's the biggest of them. So here in this axis, we have each scenario. So this scenario is 14, this is opening. 15, this is opening, and until 26, this is open. So here we have the cost. And as you can see, the transportation to stores decrease when we increase the open disease. And this is the logic, because if we have more disease, we are closer to the customers. So we travel in a less distance. But if we see in this part, when we move to 24 disease to 25 disease, we see that the cost increases. This effect is because we have the constraint that to serve also a minimum number of stores. So even if we have a customer far to our DC, the software have to accomplish this constraint. So they take that customer and achieve the constraint and all the rest work. So it's important to consider this type of constraints that affect our configuration network. The follow cost is the disease cost. So in this case, while the cost of disease increase as the number grows of disease. So in this case, we can see that our change between a cost and another cost is not higher or is not significant, but that has also a reason. So the reason is that we have a lot of options to choose the size. We have 7 options. When we have these options from a little size to a bigger size, we can make easy changes and not incur in big costs. So it's important to consider that also. And we did another exercises, and in one of them, we see that we have only like 3 or 4 options of sizes to choosing. The cost and the different costs was higher than in this scenario. So it's important to consider this type of option, a flexibility that you gives to the network. And the last cost to consider is the inventory carrying cost, that in this case also is not significant, but it is because a higher proportion of products of portfolio are of high turnover in the company. So now we're gonna look the total cost. So the total logistics cost that includes the cost that we see previously. So with the total logistics cost, we can find the optimal theoretical solution. So in this case, is open to a 19 disease here. But if we see the difference between these costs are not relevant. So we have to, we prefer to name like optimal zone around 18 disease and 21 disease. For this optimal zone, we can see the configuration of this network. And in this graph, you can see the location. There is some cities of territories of Colombia, and the size of each DC. So each square represents a size. So here you can see like the yellow represent the 7,000 square meters, and the bigger, the blue, is 22,000 square meters. So we can see like a little trade-off between sizes and some location in our network. This type of graph is useful for customer because guide in decisions and how can we move to a number of disease to another with a little or a less impact. In this graphic, we can see only for the theoretical optimal, there is 19 disease, the throughput and the number of stores that each DC can serve, or serve in this case. So it's important because if we compare, we can see that, for example, Soacha has 200 customers to serve, and Jumbo has approximately 400, but it's a big difference in terms of number of customers. But if we see the throughput is higher in Soacha than Jumbo. So it's important to see that because that graph show us the difference between the demand in the regions in our country. So a lot of customers not necessarily represent a lot of demand. And here we can see how is the configuration of our network. There is a mix, as we say, between a lot of sizes of disease and different cover areas per region. Thank you. Go ahead.
Thank you. Thank you, Iovanna. Well, before getting to the insights we already achieved from this business case, I want to address some elements that we must face it during this project. First of all, probably you are asking yourself, why those sizes? And that is related because, I mean, it's not possible to build a distribution center of any size in different places in our country. So we must take into account that fact. That's why we already established, specific sizes that are capable, to build on those places in the country. As you already noticed, and Iovanna mentioned it in the last slide, and what's interesting also to remind you a little bit of that, in this case, the demand are spread not accordingly, let's say, with a, let's say, linear rule or something like that. It's different according with the region. That's why the sizes, that we already came up with also shows us, that probably in small places, you're going to get a different size of a distribution center than the biggest places, which is a high density or high demand density there, for instance. So all of these elements let us, let's say, to create a kind of let's say, customized solution for the company we're talking about. But what was the lessons learned from this project? At the end, what we already learned from it? Well, from many things we already learned in this project. Let me tell you some element we already work with in this, was related with the way we are using anyLogistix, because let's say we try to use the tool for doing at the same time two main functions: calculating, let's say, the distribution size, but also deciding where should be located at the same time. Try to mix it in the same mathematical modeling equation and everything related with that. So we already understand that the anyLogistix was capable of giving us a really powerful solution, and not just a solution in two different steps. We already put that in the same model, which is, of course, wonderful for us in order, let's say, to get a really powerful solution for our customers, But also, there are two things I want to mention right away, as you're seeing here, some of them in this slide, okay? If the logistics network must grow, so the optimal growing implied a mix of distribution center size in dimension and throughput to the number of stores to serve an area to cover. What that means? In this case, we need to, let's say, to work with some specific constraints, such as the minimum number of customers that each distribution center should serve, for instance. Also, we need to move, let's say, to understand that the maximum distribution center size, and that is important also to get into our minds. And why it's so? Because, keeping in mind these elements, let us to create a more realistic solution. And at the end, that's exactly what we want, create that precisely, a more realistic solution that was easy to implement for our customers, that let us the enough information to move forward, to starting with this new, let's say, network configuration, and also getting really important results in terms of service levels, and also in terms of costs, of course, also in terms of efficiency as well. Okay, and the second element we want to address right here, and this is clearly important. This is a really important message to send to the whole audience today. Less flexibility means more costs, and that's important. At the very beginning of this project, we were starting with 3 different sizes, but the results were really, let's say, useless. It was not as the company expected. That's why we decided to increase the number of sizes, in this step function that Iovanna's mentioned previously, in order to get more flexibility. And that's a really important element, okay? If you want to work with complex, supply chain networks, as we did in this company, you need to think carefully about how flexible that network can be. Okay, and that also gives you a further step of this project. We end in, let's say, with the supply chain optimization, but also we're opening, let's say, the door to do an additional element, which is more focusing on the simulation side. Okay, of course, the simulation side wasn't part of this current project. It's out of the scope of this current project, but also, let's say, could be somehow the following step, the natural step to test finally the network configuration is achieved, on this modeling. Okay, so we already take into account these several things, and I'm going to give you this just to end in our presentation with that element clearly understood. Flexibility is the key. less flexibility means more cost. Well, thanks a lot, for hearing us. And we're ready for a Q&A session. If you want some questions there, we are ready for answering as the best way we can. So thanks a lot.
Thank you, team, for this very insightful and rich for the takeaways presentation. So I really like this case of when we are not only just producing and we're trying to extract the optimized structure of network, right? We're also trying to solve the strategic capital expenditures task of what size of distribution centers do we need in our supply chain. So it's a really good case into portfolio. And thank you again for this presentation. So in the question and answer section, we have a question. So can the model take into consideration the cost per project management to open all these distribution centers?
Well, in this case, we didn't take that into account, but of course it's possible. You can add all of these elements as a part of the modeling element. You can add this if you want as a kind of a fixed cost to the model as well. So yes, sure, should be possible to do it. Why we didn't do it? Because in this case, wasn't so important for the company, to get this is in motion, let's say. And partly because they're located in a really far places of the country, which is not so costly. So that's why they decided not to take into account. But of course, it can.
Thank you, Enrique. Another question comes next. So could you please elaborate a little more about how you determined these ranges of sizes for distribution centers to consider in your model? So.
Okay, well, as already mentioned it previously a few minutes ago, at the very beginning, we started with just 3 different sizes, a kind of a higher size, medium size, and lower size. That's it. But why would it come up with more? Because we already noticed after running different experiments that the solution, wasn't the perfect one for saying in that way. That's why we decided, let's say, to come up with more sizes in order to get more flexibility. And that the number, in this case, using 70,000 square meters and 80,000 square meters and so on and so forth, was something that we already work with our customers, directly. So in those numbers are related with the number of the size of the disease that the company used to work with. So that what we already, just let's say, if we're giving more flexibility and understanding if those sizes were capable to build it in the places we are working with. So we already take into account let's say, the reality of implement that solution, but also we already come up with the sizes directly with our customer.